We're going to keep this room open right now, and I'm going to pass the mic to Sir Mix, who's going to keep the deep dive of Plutus going. Hey, man.
Hey, everyone. Sorry, how are you? And unfortunately, I came late, but yeah, let's dive in. So first, let me share my screen.
And I'm going to disappear in just a few minutes too. I have another meeting that I've got to get to. So okay. Here we are, two nutty professors kind of racing in and out of the room. Feels good.
Okay. So before starting, does anyone have any question from last session, or I mean, what we did? Hey, Dagwood, how are you?
Doing fine, sir. Good to see you. Looking forward to this.
Great. So no question. Okay. That means mostly, there is a two condition. Everyone understand everything that I said, or everyone didn't understand what I said. So I hope it would be the first spot. Anyway, let's somehow a small review from what we discussed about last time. That we talk about the business rule, business logic inside Cardano. Inside Cardano blockchain, which we found that in UTXO model is quite different than Atom model, and when a smart contract comes and gets a role to play, it is not like what you've seen in Atom model, like in Solidity and Ethereum or in other blockchain. And in fact, you need to just focus on this cashier, and when transaction happen, the validation happen. And see you soon, Steve. So your on-chain code, in fact, only have the logic of your business must happen only about the on-chain code when the transaction or interaction happen. And the transaction normally is made between two people, but it can be between several people. But this is the simplest a basic idea of this kind of business logic, but we can explore more. Like, for example, on-chain voting, which we can use same as estate NFT to track the voting. And I don't know, maybe you guys know about the Lobster Challenge, which happened around September last year. And it was like that the estate token, an estate NFT. It wasn't NFT in that time, but the token was the main thing that we were tracking as the voting was going on. And then we talk about the different kind of data that we can have inside a business idea, which normally we can categorize this data based on how often they happen or how often we need them. For example, with customer, the data about customer changes rapidly, or in your business idea that I'd ask you to think, you need to think about what data changes rapidly, or in each step or each transaction that data changes. And then we talk about the prices that that data sometimes changes and often changes, which we can determine that when that data should change, or when, and if the data change, what happens at the end of this in this section, that a transaction happening, and when the Plutus comes here. So, and there is another data that most likely any business have, which is constant. Like in the example I gave about a section of the store that customer wants to go and buy agricultural product there. So that should be stay there forever. Or someone or customer wants to go and ask a service from a department, that must stay consistent and stay constant. So those data comes inside your Plutus logic, and you need to create that business logic that today we will explore together in this game, in form of Datum, redeemer, and contract. And why I'm saying about why I'm trying to put this data idea that often and they rapidly and the frequency of this data inside your mind, because what we are seeing here is not the normal Datum or the redeemer that you've seen in previous project. Here it's parameterized game Datum and redeemer. And of course, you have heard that the redeemer is kind of like a key, and that key will unlock the UTXO so that you are validating and can produce output UTXO by that validation that inside that transaction. So imagine if your redeemer is always constant. There is no parameter in that, and everything is constant there. So what will happen that if someone gets the hands of your redeemer, can really unlock and can actually abuse your contract. So yes, this key should be not constant, but not should be very rapidly changing either, because that again create complexity, and it would be very hard to track about what key should do like unlocking the UTXO right now, what key shouldn't. So the balance between these is the key, actually, is the idea that is, of course, it's depend on your business and business rules. And the same for game Datum, and why we parameterize game Datum, like adding this byte string, which will be the hash of the answer in this game, and then the player choice, because we want to integrate and somehow entangle Datum and redeemer together. So in fact, the Datum will have a part inside the key that's going to unlock the UTXO. And as you can see, this player choice is same as, it's the same, but we use it maybe here because at the beginning, the first player doesn't need to provide his choice inside the Datum, only the hash. But when the first player going to reveal that he, she, or she chose that number, to want to prove the second player that I choose this number, and that time he has to put that choice inside the Datum. And inside the logic, we will see that based on variation of game Datum and redeemer and these parameter, we can define different condition, which actually the Haskell, we call this pattern, and this pattern going to produce a very deterministic result. And after talking about this, we've seen that underlying the redeemer, or here is game Datum or game redeemer, which we use, which is used in the game validator. In fact, there is built-in data. So what gets stored in on-chain and into the code is built-in data. But the question arises how a game Datum, which is look like this, change into built-in data. And we've seen that there is a function called toData, and we can actually explore that together. That takes the game Datum and produce something called data. So in order to in order to somehow like play that with that data and the function related to that, we need to import several libraries. PlutusTx. No. Importing PlutusTx that is class dot sorry, is data dot class. Yeah. And I think we can now ask for data information, and as you can see that the data has a constructor, and this constructor means that you can use these to create your built-in data, or the datum or redeemer, or even in a script context by these. And so far we don't need something like more than this. All of those datum, redeemer, all of those data that's happening inside your business can be represented by byte string, integer, list of data, or map of data. And this constructor is actually going to help Plutus core to identify that when you are here defining several keys for different conditions, you are referring to which one based on the index. And we see that index of self, the first one is 0, and it is 1 and 2 and 3. And you have seen these numbers inside the datum and redeemer that you can produce and try to interact with. And as you can see, there is this 1, and it fills its bytes. And if it is redeemers based on this constructor, I can come here and say, okay, that was revealed. And there is a function called toData, which can take that game datum or redeemer with any of those combination and convert it to this data that, again, with some built-in function that you don't need to worry about, will turn into the Plutus core. So we try that with like first let me import the game data to game types, game types. And I should set that extension, so I can use a literal string here. And then to data, using $sign as a bracket, and game as a game datum, and I can provide, let's say this is a built-in byte string. And then if I just say nothing, that if you recall that first player submit that datum, and this case a start datum is actually something like this, starting data. Inside the data to JSON, you can see that first player start this one. So we can say, and actually I can use this SHA too, but idea is the same, that I provide the built-in byte string here, and then nothing. Let's see, does it works? Yeah, that would be the datum. The datum that actually the honest datum, and the data that you are giving to your Plutus core, and Plutus core will interact based on this and do some logic, produce the output, I mean the validation that true or false. And we can also add like player choice, like just let's say 1. I should put that inside. Yeah. And you see that this is again outside of that. And there is another function that takes this form of the data and give us what we have seen here. So that the name is very simple, from data. And we can again use this, and then inside the whole bracket I can put this one here, and then I need to just specify that this is I'm referring to that this is a datum or redeemer. So I will use maybe, and this maybe is because the from data produce a maybe, and as you guys know, again, maybe produce always two output. One is just, which means that just the result, so the result exists and the result is correct, and nothing. And maybe is very good function, a very useful function for error handling, that you can use this to get, if there is a something here, I will get the result, like just the result. And if there I get nothing, it means there was an error, and then you can handle that case. So I'm using game datum, and as you can see that this says, okay, just game datum. So what if I gave this function like a different constructor, let's say 4, I get nothing. So it means that, yeah, this game datum and this constructor doesn't have some, they don't belong to each other. Or if I give it to 0, I get just 0, same as what we can get from the outside data. So now a question comes, how these types that we are seeing here gets indexed and then gets introduced with to data or from data. For now, it's for compilations for to data. So, because you don't see any to data here or even here. And as I mentioned before, that wrap at the compilation section is going to take all of these like name and like game datum, game redeemer, and a script, and change our convert it to this. So in order to put this function works properly, we need these player choice or game datum or redeemer gets indexed, and we need to give an instance of to data or from data to them. So the role of that and the function is going to do that is this: unstableMakeIsData. So let's look at the documentation and find out why it is unstable. I mean, what's the reason? I should mention that in last session, when I was talking about the documentation, when I created the document, that documentation was public, so it wasn't like the documentation that you are running inside your machine. And I honestly, I didn't find a place from the home page when you run that command, that the command, I mean this command, build and serve docs. I didn't find a link to the local. So this is the local one. So, and you have to write it manually, add doc after the link you get from here, from this. So you will get, I mean, forward and redirect to your local documentation, not public one. So yeah, I mean, this, I don't know why they didn't give a link, because if there was a link, and if you click on that, you redirect to a public one, not a local one. Anyway, and inside that, let's search for that unstableMakeIsData. So it is belong to PlutusTx, and as you guys already know, PlutusTx is the library that do all the on-chain stuff. And as it says, unstableMakeIsData, said generate from data and a to data, which we already seen. Instance, and again, instance is kind of saying that these function, that like game datum redeemer belongs to these two function, or these two function belong, like making friend between each other. So any other function wants to use game datum, say, okay, you are friend with this, so I can use you. This is the paradigm inside Haskell, and we have something similar inside imperative language, which call it interface, which you packed different object or functions together, so they can recognize each other. They can use different method from each other. So instance in Haskell is like that. So unstableMakeIsData generated from data to data to that game datum, redeemer, or any type that you are going to use in off-chain, and you want to change it to data. And as you saw, the only thing that we can create to interact with Plutus Core is that data, is this JSON stuff that we seen always here. So, and then this may not be stable in face of constructor addition, remaining etc. And so, yeah, there is a way to add your constructor, and as you get those indexes, you can add that. You can subset, you can do some arithmetic stuff with that. Although it's not advised to do that, and as it says, it's unstable. So if you use these, if you do some operation over your game datum or redeemer, the data under that, the operation, not the game datum, the operation for the data that's going to produce, if you do that, this function cannot track that, and it will create different constructor. For example, the constructor might be in your JSON file, be like here 0, but in fact, because you did something about that constructor, and that you adding one to it inside your Plutus code, for whatever reason, for inside Plutus code, you can do something, you can do many things, and this function cannot track that. And inside Plutus core, still that is 0, but you are getting 1. So yeah. Also, after changing like from Plutus 1 to Plutus 2 or Plutus 3 in future, this there might be some breaking stuff. So they don't say that we are using we will do everything compatible to each other, but we can as I said, that use MakeIsData index if you need stability. And now after this, I will change that, or somehow refactor that to MakeIsData index, so you can see it. So if you go to the source, and let me zoom in a little bit, unstableMakeIsData, in fact, in underlie use MakeIsData index. So the stable one, still this unstable use the stable one, but it is giving those indexes for constructor getting from a function default index. And if you look at this default index, I know it's complicated, but if we look at it's kind of array, it's kind of list of numbers starting from 0. So this index is just a default and say, okay, I'm giving you 0, 1, and 2, and 3, corresponding to name that you are giving. It's like a loop. It's giving back. So although it's unstable, but it is not unstable or dangerous as you think. This is just underlies use the same stable version, but the main advice is here: do not rely on what index is this function giving you. determine those index by hand. Use it by hand and determine it. So every time will be same. So that's the whole advice here. So let's refactor these guys. Like let's start with player choice. Let me comment this. And PlutusTx, I can just make his data index, and I'll use play choice. Let me just give it the space so we can recognize it better. And then we'll go with this kind of a style. First, I'm using 0 as a name. Sorry, it should be like this. Yeah. And then a number. That's all. You are giving a direct index. And then I'm going to I have some kind of AI that's helping me to write code easily. But let's say this is one. I mean, that's wrong, but this is. So yeah, this is actually the same. It was 0 was 0 and 1 was 1. But now we are defining very deterministic style. It won't change in Plutus 2 or Plutus 3, or even you do addition or subtraction or anything with these. Yeah, so you can do it. For whatever reason, you can do it. So let's do for game datum. The game datum doesn't have that much, I mean, but still we can, it's advised to, do it. So yeah, let me refactor this make is data indexed and game datum, and let me comment this out so I don't get error. And here something like a list, I'd say, okay, game datum just with one extra and 0. That's all. And here again, I'm going to use same thing. Let me comment this out. PlutusTx make is game data, game redeemer, sorry. And I say play 0, and reveal should be 0, it should be 1. And this claim, let me claim by first player would be 2, and the second claim by second player would be 3. So, and that's this is, and as you can see, same thing in other projects, especially in Bounty Score karaoke. You can see that inside your bounty type that we have defined this, like as you can see, for bounty action here is in fact redeemer. And as you can see, we see the cancel, 0, update, and distribute. And if we just coming out and try to compile it, let's see, do we get any error or compilation error or something? No, we don't. So let's try something out. Let's see that why we do this. In fact, let's we can start from, I mean, this is the default 0, 1, 2, 3, but does it have to be always 3, always 0? No. Let me I choose it like 10. Yeah, I can do that. Again, let's recompile and see, do we get any compilation error? No, you don't. So again, let's import those libraries and try to first importing, okay. then importing the PlutusTx, and then importing PlutusTx dot is data is class. And now let's say to data $sign. I'm going to use game redeemer, and I would, let's say I will use this again, like the play. What was the I should choose a choice. Let's say 1. So data constructor game redeemer is not in a scope. So let's see, did I sorry, I did it wrongly here. I should say 1. So what's the problem? Play choice. Let me, without this. Yeah, I shouldn't use game redeemer. I mean, I had to. I forgot. I needed to use after this equal sign, not the one before that. Sorry for that. But if you can see that, yeah, constructor now is 10. So what you define here will be the end result, and it would be always the end result. So you want to be 10, go for it. If you want to be, I don't know, 100 something, go for it. It doesn't matter. So that's the thing that maybe is important in your business logic, but it depends. So now you can change these indexes. Let me stop for a second and ask you, do you have any question, guys? Let me check the chat. So I don't see a question. If you have any question, open your mic. Feel free to ask.
Hey, Mix.
Hey, how are you?
Yeah, all right. But this game is a guessing game. Yeah, it's like I didn't see the high-level description. It's like one player guesses a number and another has to guess what he guesses. Yeah.
Exactly. The first player is going to guess the number that second player is going to choose, and it is 0 or 1. I mean, we have 2 options to make it simple. And then first player in game this instruction, I'll explain it. First player has to provide the choice that he or let's say he think second player will choose inside the datum. So the first transaction would be first player put the choice inside the datum that say, okay, second player, you are going to choose 1 or 0. And then second player going to play the number that he think like 1 or 0. And then now the condition happens, which we'll see inside this. If the second player, this is the play, second player choice. The first player starting game is outside of Plutus, because you can send any UTX to anything at this for currently in Cardano. You can send anything to any addresses, even if that address doesn't exist. You can send. So you don't have that much access, that much control that you determine. First player sent UTXO with datum or with datum hash or something. So if, for example, first player sent a wrong datum or wrong amount, here we decided in game compiler the bet amount should be 3 ADA. Let's say the first player sent 5 ADA or 10 ADA or less. That UTXO will stuck in that contract forever. So you need to bear in your mind, especially in your business logic. So you have to handle the first interaction of chain, and you have to craft it very carefully. So if you mess that up, that UTXO will stuck in that contract forever, and you cannot unlock it. So let's say the first player sent everything very good and correct. the second player starting play, and the second player has to consume the first player UTXO, the UTXO that was sent. So how do we tell to our Plutus contract that this is the correct UTXO? Let's say there is this contract, like 10 players are playing. So how do we tell this? We with a state NFT, and that NFT is like a token will sit inside that UTXO, and we can track that, and we define the details of that state NFT here. So second player play it, provide the datum that was crafted by first player, and use a play choice redeemer. And as you can see here, we already crafted second player datum choose. Okay, and second play choose redeemer. So, and after this, we have three different conditions. First is first player is winner. He won. He predict that number correctly. So now he has to provide his choice to prove that he was the winner. So I'm not talking about the hash right now. So if he's not the winner, second player, by using this redeemer claimed by second player, can claim the win amount. But there is another condition that the first player send that UTXO inside that contract, and the second player didn't play before the deadline. So that UTXO shouldn't stuck in that. So we have to provide a way for first player to claim his amount. Yeah, he paid. He has to pay 2 fees for that. But anyway, that's a bummer. But we have to provide a way for that. So we use that here. That's claimed by first player redeemer, and here we say game datum. And when we use this underscore, it means whatever, it doesn't matter. Did you provide this or not? But he has to provide, as you guys know, we are providing, and you can see it in game instruction, that, for example, first player start a game, it's just the datum output hash file, which is the file that we are sending, the hash of that we are sending. But if we see that about the redeemer and for any other condition, we have kind of 2 datum. First datum is TX in datum, the datum that the person was hashing the UTXO. And there is output datum, which we say TX out datum embedded Y. What's happening inside your logic here is not based on the TX in datum. It is based on TX out datum. So you need to remember that the TX out datum, you are making these logics, at least in Cardano CLI, not the one that you're getting. You can do some stuff with that, which we will see here about deserializing the datum and using these functions. Where is it? Game datum. So we can say the output datum, like here, is equal with the output that we want. Why we want? If we look at this output datum that we want, and the second player has to provide exactly this output, because in if the first player is winner and wants to provide that output, that datum, sorry, that should be the pattern. That should be the datum. So in this condition, we are somehow connecting these to this. So the second player doesn't provide corrupted or wrong datum. And this is, and we will look at it and how this works and how we deserialize it and so on. But just in this session, don't worry. But anyway, so this is the logic. that this game is going to play. And in your assignment, yeah, this is a rock, paper, scissors. It's 3 options. Yeah, I know it's complicated, but the basic idea is kind of same. First player predict, second player choice, second player submit choice, and then at a third stage, first player try to prove that he was winner. If he could, if he wasn't, even if he tried to use this option, he couldn't because the choice is different. And we will see how we will deal with choice. And after fourth step is for second player to redeem the win amount, and there might be actually just a game with 2 steps. The first player try opening a game and no one's participate and he wants to close the game. So that would be this. And what I was okay. Did I answer your question, Alex? I mean, was it clear?
I kind of got, yeah, what I was asking, but yeah, there still is some things that I don't understand, but that's all right. If like, I don't want to take this away from what's going on.
It's okay. I mean, it's okay. I mean,
yeah, well, it's like, I just don't understand why, like, it's like 3 steps, because what you say is like, player first guesses a number, or guess a number what the player 2 will do. And then the player 2 makes a guess, and then player 1 has to send another transaction, yeah, to the smart contract to confirm his original choice, right?
Yeah.
But
why we do this? Why we have to provide 3 steps? Because everything in Plutus contract is transaction. So every choices, everything that we have to like proving that the game start by first player. Okay, how we can prove the game start? A transaction, a UTX. Okay, and others. How we can know second player start playing and provide the choice? Another transaction. How we can know the first player was right? Another transaction. You see, this is the
well.
I know.
I have to disagree here. You know.
So how
we can know that the
play?
first player was right if like. Yeah, if like you have his guess in the datum, yeah.
And his guess inside this game was hashed. So we didn't put the plain text 0 or 1, the choice. That was the that's it. That if you look at that, we
I get it now.
for producing that. And because if the first player put the choice very plainly, of course, second player for unlocking WTX has to have the datum. There is no way. This is the protocol rule inside Cardano, and he can look inside that datum and see, okay, that was the first player choice, so I will choose another number, and I am the winner. So we implemented a hash using this SHA-256, and this is actually using Lipsodium hash library, and then convert that hash. So because you guys can see the hash is you've seen hash before, but if you run this let's see, let me run cabal run hash of answer. What was the name? What, that's a script, I forgot. Create hash of answer. The hash you are going to see is not you are used to see, because this hash is what would be inside Plutus core. It cannot be a very literal string. So it has to be something like built-in byte string. The hash is a byte string, we all know. But this is, so inside that logic, inside this 0 1 gate we are seeing, there is a function this check nuance, and nuance is the word that we provide here to create different hashes. Because as you, Alex, you know already that hash of a string will be always same. So hash of 1 will be always same. Hash of 0 is always same. And again, that would give a clue to second player that first player choice is what. So, okay, that will see you. So we use a nonce, which is this. I just use this so I can show you.
Yeah, I understand. So you hash one and nonce, and then the hash is you cannot predict it. Yeah.
Yeah, and that hash will become the datum. So this is the hash of the what you are seeing here, and actually you cannot decode that in very normal. And then inside this logic, there is we will provide this byte string here, and then we will provide the nonce, this guy, we will provide that, and we will provide second player choice. So this is the 3 argument. We will provide this, and inside that, we will say, does this hash that we got that this PS as a byte and this hash is same as the hash that if we put second player choice and same word, same nonce, we get the hash again. So we are now here comparing these 2 hashes, like a first player hash and second player hash. And if these 2 match, it means first player number was correct because he chose 1. And second player also chose 1. So now the hash are same. But if the hash are different, it means that first player choose different number and second player is the winner. So this
but I have a question.
Go ahead.
If like, okay, we have if the hash is matched, can we make in the smart contract functionality so that like if the hash is matched, we automatically send the funds to player 1?
No,
and if they don't match, we
that's
cannot
the
do
thing.
this.
No, you know, the last session, a person, Ava, I think, he asked me, does Plutus in the normal, this Plutus language is a Turing complete language or no? And I gave the answer that it is not. But actually, in fact, it is. I mean, I did a little bit, I kept it here. So inside the documentation, in the Cardano documentation, you can see that Plutus native smart contract language for Cardano, it is a Turing complete language. And what this means, and why it means that it can do all sorts of computation for you. And it can run any program. But why I said no, because what you see here as a validator is produce only one output, true or false. So I still don't understand how to. Maybe the Plutus, which you can write off-chain code with that too, and there is all sorts of stuff, is Turing complete. But what you see here, like PlutusTx, I think still not Turing complete because you cannot run any program with it. This is a very limited function that takes 4 kind of or 4 input: datum, redeemer, script context, which is the information about transaction, and contract parameter, and produce the 0 or 1, produce true or false, nothing else. So you cannot send something. You cannot do anything else with this validation. That's a problem. So how you can do that? Off-chain
validation.
You can automatically do something like this in off-chain. But your contract cannot do sending data or sending amount or retrieving anything. But in off-chain, you are free to go to do a lot of stuff.
Okay. So in contract, you can kind of make the funds unlockable by one player or another player, but they have to do it with a third transaction.
Yeah, and this is just a validation. Like first player is going to be winner. Plutus come here as a judge. Plutus is like a judge. Say valid, no. He will not do anything for those players. They have to, as you can see in the game instruction, they have to craft all these commands to craft correct data, correct, even running this kind of a script for crafting the correct datum and redeemer. And I added these two new script to create the correct data, correct deadline, game deadline, and reveal deadline. And even I just add these two for the sake of like explanatory, explain that what's going on with this hash and address, which we'll talk about in coming minutes. So everything that should be in off-chain, off-chain, off-chain. Yeah, in Ethereum, no, you can, that contract can send. And that's why hack happening inside Ethereum or any imperative language blockchain. Because your contract, if there is a flaw in that, which we'll see, there is one of the topics that I'm going to talk, I hope today, is hack the logic. So we will find a flaw in our logic here, and I will show you, but I don't know, I'm not sure to fix it for you because I don't know, I talked with James to leave it like this, and I'm going to give you guys to fix this flying wrong logic inside your assignment. So yeah, I'm giving you too much, but anyway, there is a flaw here, and I will show you how we can actually bypass this security. So the logic is flawed, and imagine this logic was flawed in a contract that send amounts to you. You could use that and send all the UTX or all the amount inside. That's the hack happening inside the Ethereum imperative languages, which gives a developer so much control, so much power. But that power is going to actually ruin many people, because we are talking about people funds. $10 billion last year, 2021, was lost just in Ethereum. 10 billion. That $10 billion is people money. It's not, I don't know, some government or some institution, like a financial institution money. That was the people. Did they did something? Did they care? No, they are still going. So inside Cardano, they decided, no, we want to be very limited, very deterministic. And yeah, using even Haskell, which is again very deterministic, very difficult. And I know. So your contract cannot do sending, cannot do it. They purposely took all of this power from the contract. Although they are providing a sidechain, and I've seen this sidechain hacked. Someone got hacked in Milkomeda sidechain in Cardano. Somehow the MetaMask, the wallet that he connected to that sidechain to convert the A data to M data, which is stuff for Milkomeda A data, that was lost. So yeah, that sidechain which is running Solidity, and that Solidity get translated to Plutus, and Plutus to Plutus score was problematic, because that Solidity was, I don't know, still the people are trying to find out what was the problem, and they still didn't find it. At this how a person got hacked. Yeah, the MetaMask wallet was hacked in one of the user in Milkomeda. Anyway, I hope that let's look at the Justin question in chat. Could you write the redeemer just like how it is in 0-1 game, but have an integer accompanying one of the options, like redeemer equal play integer, reveal integer? Yes, of course you can. But there is a problem. What is the problem? If you are, you see, instead of, Justin says, instead of going with player choice here, why not going with literal numbers, integers, like 0 and 1? Like instead of using player choice, we say play integer, reveal, and although reveal here is not integer, but I mean, as an example, but here, because reveal is a hash, the hash that is going to get comparison here. But anyway, let's say integer. Yes, you have kept that option, but here why we didn't? Because we are going to do this stuff, this comparing, and we decided to choose types instead of very literal integers. Because inside your Plutus core, literal string literal string is not possible. I mean, it's not possible to put a literal string, like various. And if you see this 1 and 0 here, they are actually byte string, and we define it's built-in byte string. So, but what is byte string is like kind of this. Where is datum here? So instead of we choose this byte string, we say, okay, there is a byte string, and the byte string is just 1. Byte string just 0. This was a like clever way to inject a number inside your Plutus core. So and here we are saying that, hey, you are going to comparing what types. Here is it comparing types. As you can see, it's just in Haskell, types comparing between types is kind of difficult because the Haskell is a strongly type, and you have to define that type. And as you can see here, even we choose 0 and 1, we say 0 equals 0 is true because we had to put this inside Plutus core even. So in normal Haskell, you don't have to. In normal Haskell, 0 equals 0 is true. I mean, you can check it out in a standard Haskell, and 1 equals 1 is true, and anything else false. So here in this function, with second play choice has to be a type. So we can check this byte string with this BS is the byte string we get in reveal, because it's check nonce where we use that in reveal. No anywhere else, just we use it once here, and we are providing BS, nuance, and choice. Okay, Lucas, see you, take care. So, and we are where we are getting this BS, we are getting from Datum, and nuance from the reveal, which you see that here, the Datum, the redeemer has to provide this this hash, this sorry, this is not the hash, this is the nuance. I said it wrongly. This is this one. We will provide this one. In the data to JSON, you see that we see the nuance, and inside first reveal, we see the reveal nuance. So yeah, byte string for reveal is nuance, not the hash. We provide that hash already with Datum. And the choice is again, choice is this, and it is what type, that type, it is a type. So I think that was the problem. I think that is just the problem inside Plutus, that for comparing, you have to go with choice. But is there any way to go with literal integers? Maybe there is. I'm not sure, because if you run this contract, you get around 700,000, around 800,000 loveless to pay. It's big. So, and the game is simple, but still it's big. So in DXs like SundaySub or other, they wrote their contract, but they decided that that's too big, that's too expensive. So they decided to go with these very low level stuff. So they went to very deeper, like instead of going with game ready-made, game datum, very simple stuff that you can see here and very understandable. You see the whole ready-made, we can define it like here, put the parameters here and done. But if you go there in deeper and you want to do everything by your hand, yes, you have to use all those constructors, integer, byte string, list, map, and then inside that you have to follow and you have to remember, in fact, in your code that what was the indexes, because you are writing everything with that. But at the end, your contract, for example, the size, this is the contract keyboard, as you say, this guy is big, will be much shorter, and the step execution, which we're going to see, and actually next session we will talk about hard limit, which you need to remember the hard limit and the limitation that you have right now inside Cardano for how big how big your contract can be, or how much execution, how much CPU and memory usage is going to consume. There is a limitation right now. So you have to follow that, and you have to be under that. So yeah, they decided that to do that, but yeah, that would need a hard refactoring. But I really encourage you, if you think you can do it, yeah, go for it. Again, this code was written originally by Laris, head of education in IOG, and it was taught in week 7 of Plutus Pioneer program. But based on my understanding, for comparison, it's better to have the types like this, especially when you are going to use a SHA and SHA-256. If you look at inside the documentation, it says that you have to provide 2 built-in bytes. You cannot provide like a number or integer. So let me check it out. SHA-2, sorry, I just Control Control S, SHA-2. Internal, it is inside internal. I mean, you can find it anywhere here, but here inside internal, as you can see, even here, built-in byte string. So at the end of the day, if you want to use this function, you have to somehow convert your integer choice to built-in byte string. And again, Haskell is very strict. You cannot say, okay, now it's an integer, accept it for whatever reason. No, we can't. You have to provide built-in byte string and built-in. That's why, again, here, even in this smaller script, I choose built-in byte string. I didn't say this is a byte string or a string and then using some function to bring a string to text and text to byte string and byte string to built-in byte string. Yes, you can do it, but that is a execution part, a step that you need to pay it. Your user has to pay that. So I hope I answered your question. Let's go for something that I wanted to show. So yeah, converting datum, and we saw that those functions and converting datum and redeemer to off-chain usage, which we can see here inside. This is off-chain, then you have to do it off-chain. Yeah. But you have to follow that. As you see, I imported game types, and you can do it, but you need to, if you have a script that you are going to import some of the contract stuff like compiler types or anything, like let's say the 10 files exist, and one file is for types, another for functions, anything. So if you, in order to import that, you need to go to your cabal file, and after defining your executable, let's say, where is this? Yeah, like this is data.json, just include the 01 game, the same name of the cabal file, the same name that you are putting inside that. So it recursively going to look and find here your expose, because I've seen this mistake in some students do, to create and something like outside a script. So by doing that, you don't need to define or copy everything here, or bring in everything and getting some errors, so like, and even importing a lot of stuff. Just importing put done. And yes, I mean, this is the style that I wrote. You can do it better. Of course, there are better. I try to separate it so you can see that which belong to, like, these two belong to the second player choice. And so the redeemer is different, that Datum is different. And again, as I said, the second player choice, and again, seeing game instruction would be the output Datum. And your contract logic will deal with that. And as you can see, again, with this function that we are going to see, your output Datum will be comparing here with a function or something. You can use your input Datum, but more importantly, it's about output. Because if you send your, even if you send your UTXO in wrong Datum, yeah, that UTXO is done. You cannot retrieve it. Or although if you can keep that Datum, but if you do not keep this condition, like here is output Datum, let's say this was a different. Let's say we didn't have this. Second player could choose anything, and here the first player couldn't use this whatsoever, because this is the condition, and he has to have this pattern of Datum here. So yeah, you need to be careful. And if the person doesn't do that, the worst case scenario is the transaction failure, even before submitting. So yeah, I mean, the cost is very low, and so you take care of that inside your contract. And if the person sent the UTXO without a hash, without Datum hash, yeah, that's done. I mean, you cannot retrieve it, at least in current protocol. You cannot retrieve a Datum, a UTXO without Datum. Yeah, I know that's a bummer, but that's a rule for now. And a question comes: what should be inside Datum or redeemer? I also asked this, and this is maybe ongoing question in among our community, that what kind of data should be in Datum, what kind of data should be in redeemer. As you guys know, again, we discussed that redeemer is kind of changing, but not that much, but Datum is changing much more. But Datum is public. So after Vasil or aka Babbage Hartford, your Datum would be public. It would be inline. So right now, if you query your, let's say, wallet, UTXO, oh, this is the contract, doesn't have anything inside it. So right now is, yeah, TX Datum none. This is your wallet. In wallet doesn't matter you have a Datum hash or not. You have the control over that. For some reason, actually, there's I can show you the very detailed, but it would be too much. That the validator has to have a Datum hash as an argument, and it cannot be null or unit or anything. So here, Datum doesn't matter, but even imagine in your contract, if you see, it would be plus with the hash, something like this. But you won't see that what is the hash, and that's actually now is a way to secure your business and secure your contract. No one knows. No one knows your data, so they cannot craft or start into, I don't know, doing some interaction with your contract. So imagine the second player doesn't get the datum of first player. He cannot play anything. I mean, he has to provide. But after the hard fork, there is a way to inline your datum inside that. But you might say, okay, the datum is inside the blockchain. Yeah, let's look at it. In CardanoScan, do I have it here? No. Let me CardanoScan. If you search, let's search this contract address I was playing. Let me just 0-1 game ADDR. Okay, let's take this contract address and see, because there was some I did some transaction with that, and those transactions had the data. Sorry, I just messed it up. Yeah. So no transaction. Okay. Let me take the transaction ID out of. I think I have a TX Stein or TX byte. So there is a. This is this command Cardano CLI transaction TX ID and TX file. We can get the transaction ID out of it. And if you come here, just searching that. Well, because I'm on mainnet. Yeah, sorry. That's why I have to go to testnet and searching. And you see, yeah, there was a transaction, and here, this is the input. Yeah, this is the output. Great. Now in the contract, if you click it, you see that this information exists. This is your contract. This is the datum hash and datum. And what is this datum? In fact, you can decode it. This is Seaboard. And in last session, we saw that we can use a tool called Seaboard Diag, and there's a -2 and Diag. Let's give it this and see. Yeah, this is the data. And you guys, I think already know 121 means constructor initial value. And if it is 0, so it is 0, as you can see here. The datum, like here, was 0. I don't know which datum was this. Maybe second player claim, I think. Second player choice. I think maybe this was that. But anyway, if you can see that this is the datum, and based on this, you can craft the datum. Yeah, this doesn't look like the datum that you can provide in off-chain, but you can get the idea, and you can craft these constructor fields, etc. And even in Bounty Escrow, we have the like this. If you use this different script that I provided here to craft a datum or redeemer based on a hard-coded, like here, or with argument, you get this, and you can see this. This is a bytes, integer, and that's a datum. It can be redeemer too, but I just chose the data. So yes, we can see it, and not only that, if you need to remember that even your redeemer is visible. Let me, I think this is the redeemer. Yeah, we see that this is the redeemer. The tag is spend. We will talk about spend. That there is a script purpose. We will in next session we'll talk about a script purpose. Why? Because as I said before, that you guys need to, in order to be a very good, or let's say full-fledged Cardano developer, you need to know about proof of a stake and how we can use this proof of a stake in your advantages and actually in your business logic. So script purpose, what was the script should be somewhere here. Dummy script purpose. That's dummy. Let me write it the whole thing. Yeah, this is the dummy. This is in ledger. So in script purpose, you guys already know about minting. So minting is a script, is a Plutus script, but it is not for validation. It is for validation, sorry, but for minting only. You cannot spend, and by spend means consume a UTXO and produce a UTXO, getting input and output. Minting is that for, you've seen it in minting an NFT or token. Spending, what we are talking right now is spending, and there is two script purpose: rewarding and certifying. Rewarding is for your withdrawing reward from a pool, but not for your wallet, but for your contract. Your contract can be staked to a pool. By this certifying, and you can delegate your script with the pool, and we will talk about more deeply. But anyway, this stuff, this spending reward means anything, and we can see it in CardanoScan as tag is a spend, tag is mint, tag is reward, tag is certified, I think. So this is that, and next session talk about more about that. So if I copy this is again CBOR for your redeemer. And if I come here and using the same command, let me delete this. You see, I got the redeemer event. So your redeemer is exposed. Not that much, but it's exposed. 124. What is 124? If you guys remember that in our, I think second player claim was 3, and 3 plus 121 would be 124. So yes, that redeemer is even exposed. And CardanoScan is not your ledger. It is not the UTXO. This is not the what we call direct graph of asset UTXO. It's a DAG, they call it. It's not the ledger of Cardano. It is DB sync. So when you submit your transaction, all this information will be inside the transaction. And when you're a node submit, one of these nodes has a connection with DB sync. Even the DB sync running by Cardano Foundation will pick it up, that transaction, put all these appropriated fee and feed that here. So right now, this is not on your ledger, but in future, this will be on ledger. This will be inside UTXO, and also this. This is the contract byte. So you need to really consider what kind of information that you're going to use here. So you have to remember, if the redeemer is kind of like this, and everyone knows how I can create a logic here. So if a person comes and like, I can, let's say there is, let's look at another contract event. Let's see there, if you go to blockchain, there is a contract transaction. So they just extract all the contract and see the spend, mint, this is mint. I hope I see the reward. And unfortunately, talking about reward is, and certifying is not that much common in Cardano. But anyway, this is the mint, spend. Let's look at this spend. And let's look at contract. Okay, this was the redeemer. Let me take it. What the redeemer this guy were using? Let's decode it. Okay, there was a redeemer that the index was 0. I don't know the code, but now I know that this redeemer was like the Plutus core got not provoke something like that got in the interaction. I forgot the word right now. With like this, the 0. So it was, imagine that it was play or something. So based on this, we can understand that, oh, so that redeemer is kind of a response. Let's look at the datum. Let's take it out, copy, and use it here. Okay, you see, this is the datum. And based on this, you can craft. So, okay, this is index 0, it is in this, I can, okay, this was a byte string. I can, okay, this is the byte string. You see? So, you have to be careful about your redeemer, and you have to parameterize it as much as possible. So this guy even didn't parameterize it. As you guys see that it was just a simple like this claim by this claim by this. And if you don't want parameterize your redeemer or parameterize your datum, you have to be careful about the condition. The pattern you are getting here must like this signed by second player or something. Okay, do you have any question, guys? If not, we will jump into the next section. Plutus smart contract logic. Okay, great. So now we know the datum and redeemer and this kind of stuff about these guys and the rule of them. Yeah, still there are a lot to know about the rule of them, because now we are not talking about what's the rule of datum redeemer contract parameter script context, these data that we are feeding this Plutus core and this smart contract, what they do inside the logic, and we are looking like right now, but still we have some brief idea about what's going on with them. So now what's their role? This is the function that let me just a little bit. Yep, so you can see the whole picture or better. And maybe, yeah. Okay, so normally in most cases, we are providing a game parameter or any constant, which, as you can see, this is the constant. And why the reason is why we choose this. And as I said, you cannot put literal string inside Plutus core. And if there is a comparison, if there is a validation that's going to check, for example, here in this function, that okay, the choice was 1 and okay, the choice was 0, you have to use something like built-in byte string. And this is a trick that we are tricking the Plutus core that this is the byte built-in, but this is not a string. Don't get compilation error or whatever. But in fact, we are treating this as a built-in byte string. Can you do other things and stuff with this? Yes. So this is a way to put your string inside that. You want that? Maybe you want that. I don't know. It's based on your business logic. But this is a way to put your literal string inside your Plutus core. So instead of 1, let's say I'm saying that my name, like my name is Ali, or I'm saying like this, my username. So you cannot put this like as a, okay, I'm saying, okay, this is the string and deal with it. No, you will get a compilation error. And if you get somehow work around this and put this inside that, you cannot get this features of comparing and like using this type for in your advantages. So this is the way. Maybe there is better way. Still, I don't recall right now. But anyway, this is a way for putting your literal string or text inside your Plutus core. As you guys see in data to JSON, this is not a byte string. This is just the dummy example of a string. But I choose a type for this. I see you guys didn't get any compilation error or something here. When I run that, I get everything's fine. So yeah, this is a tricky way for putting your literal string for whatever reason you want inside your Plutus core. Okay. And normally we will provide these at the beginning of these parameters. Does it have to be like this? No. But I've seen normally like this, that this is the parameter. The first order would be these parameters. Maybe it's a compact like game parameter, which we provided like this, or it is separately. And then datum, and then redeemer, and then a script context. And here you can, if you have, let's say the redeemer is an integer, you can provide, or even the datum, you don't have any datum, you don't care. You can just use something like unit. So it means there is no datum, just no datum. So you can use the unit as a no datum here. If your logic doesn't rely on datum, or doesn't have to. Or you say that my datum is just an integer. It's not constructor this and that. It's just a simple integer. Okay. Integer. Yes, this is valid. You can do it. As Justin said about asking about how can we put some like other type like integer. Yes, you can do it. Like this inside that we can do it as a datum or as a redeemer. But I think in your DAP, like a 0-1 game, and it's not a DAP, okay, but it can be a DAP, or in bounty escrow, we decided to go with this. And one of the main reason for this, imagine that we see now we have game param and bounty escrow data inside bounty escrow contract. Imagine it was something like built-in data, and we defined that built-in data in bounty types. Great. The problem arises that bounty treasury also use a data, which we call it withdraw data. But if we didn't define these and we just try to go with built-in data, which again, as I explained, there are advantages for that, you would get confusion. You would get maybe problem because you are using the datum that's supposedly being used inside treasury, inside your escrow contract, or inside treasury. What you are using is actually your escrow datum. So the advantage of using this high level is everything's clear. You can see it, and also you have all sort of high-level function they can do it. But there is one disadvantage about this that we can see it here. In order to like here comparing your output, you have to deserialize your datum, because the datum that you are getting from transaction, as you guys saw, was something like this. Something where did I decode? Something like this. And we can actually see that. Let me cat the transaction body. And you can see this is the whole transaction body, which will travel through nodes and then end up at the DB sync, and ready-made everything's here on the code. Let me decode this again. Cboard diag --2 diag and 3 these, and from here, it's a start your transaction. You see, this is the Cboard, and from here, it's a start transaction. This is the UTXO and their index. TX index, the UTXO TX index, and that the amount that I'm sending, and this everything, and this is the Plutus score that I'm using. And here I'm getting the datum, and I don't know. I think this is the redeemer. I think maybe these are the time. I'm not sure. I don't know. But anyway, as we can see that this is the redeemer. We solved that, and this is claimed by second player, and this is the date. So your Plutus contract doesn't get datum as this very beautiful, nice, and very clean datum, something like this. It gets something like this. So you have to deserialize it. Although we think, okay, this is a serialization. We are serializing to our beautiful datum or beautiful redeemer. But in fact, everything, the standard is like this. The standard is Plutus score, and Plutus score is the judge, and we respect our judge. So yeah, this is that. And in order to do that, we've used first a function called here deserialized datum. So datum is a type that exists inside your this is a built-in type inside Plutus. And this, when we say datum inside your Plutus logic, your contract say, okay, you are referring to this. There is a type for redeemer too. So there is a redeemer type. And if you do that, you are referring to this number, to this constructor, structure, object, whatever you can call you for this. So by this, we are saying you are getting a datum, and maybe, why maybe? Because maybe you don't, you know, maybe the person doesn't provide the datum for that. So you have to handle the errors. So if you get nothing, no problem happens. Your contract doesn't get some unknown, God knows what error. So as much as possible, go forward maybe for error handling, especially on your production level, go for maybe. And then we produce maybe datum. So we get the datum, this guy, and then we produce something like this guy. Where is it? Here, game data. So that's it. First, we get it. Where is it? Yeah, and then we say if we get the datum, as you see, this is the argument. Okay, this is the game, and datum D. We say okay, that do is a function Haskell that say okay, do some like several functions, several instructions, several steps will happen inside inside your function. Let's say several functions inside the function that like recursively do something, and then at the last line we say okay, get these output out of all those functions and give me the result. And the result is from built-in data. Take that and deserialize it. I said, if you remember, there was some kind of to built-in data and from built-in data. We can look at it here. Control S, from built-in. This is the problem of it. We have to go for the first page, so we have the access to whole documentation. So you cannot search something inside the library. If you search something, it will just try to search it inside that library, not the whole documentation. But anyway, from built-in built-in data. That's I think it should be here. Yeah, from built-in data. And it's say built-in data will be maybe A. What is the A? Maybe A. We, as you say, that it was maybe that now is a maybe data. And then we say, okay, that maybe data should convert to maybe as maybe data, game data. And then how we do that here there is a function here, we look at it and how we do that. But anyway, this will deserialize it. This will change this guy and try to create this game data. So this is another function that we're going to see. And here, as you saw, this is the output datum. And the datum we are comparing is types, is not that God knows what numbers. So we are just typing just to say, okay, this datum with this type should be comparing. That's why we have to deserialize it and create this. And let's look at the output datum. And output datum is a case. Case is like, if you guys know imperative language, there is always a expression for control flow, like if else, if then else. But that's, we call it a case switch or switch. And this is like that. This say that there is a condition, out of there is a output of this, and when there is output of this, do this pattern. If you get this result, do this. If you get this result out of these functions, okay, see you, Alex, and do this. So the whole idea of cases, and we use that case in most cases we use it for redeemer and datum here, because we have the different parameterized, and when you want to match this pattern, different pattern of redeemer and datum, you have to use this case and provide. And you can see it even in a bounty scroll, that we say that in case of action, which we say what was it, the bounty action, and we say the bounty action actually is this argument action. And in case of action, if you get cancel, do this. If you get update, and if you get distribute, do this. And if you get, how you tell your Plutus you got this with this guy, with this simple stuff, simple like 124, or for example in bounty scroll, the cancel is 0, update is 2, 1 is distribute is 2. So if we get 123, we get distribute. No, sorry, 121, 0 with 121, 122, and 123. Sorry, yeah, this is 123. This is 122, and this is 121. That's happening inside your Plutus core. That's a very low level that if you want to look at it. So that's why you have 3 different cases. So now you need to handle it. And this is the result. This is the, this is the pattern. This is the pattern, that this is the result. They do this. So inside our 0-1 game, we've seen that these are the patterns, different situation, different kind of a combination of redeemer and the datum, how their works, and then there is a result. Check this, or check this. So inside this game output datum, we are we see deserialized data. So we are providing this whole thing supposedly be a data. So it will find the data. How? There is a function called find data. Let's look at find data. So we see the find datum gets the datum hash, and TX info. The TX info is, as you guys know, the TX info means the transaction information, the information. Also, it will get the datum hash from this file, from this keyboard, which we decoded, and it will get the TX info. The TX info was this is, and then it will produce, so what is it? Sorry, it will produce as output the data. So it will give us, by using this function, it will give us this guy that you can see. So yeah, the find datum doesn't give you very clean your game datum that you see. It will give you just this. And we have to provide the datum hash. How we do we provide the datum hash? The datum hash still exists in this file. So we can get the datum hash out of it, out of this file, and give the tx info from to that find datum function, and then we will get this. Let's look at the as you see, this find datum's first argument was the datum hash, but here is the first argument is info. Well, info here is that that tx info is, if this is as you maybe you see a lot and you can use it always. Use, this is the boilerplate that you are using CTX. And let me, in very quick parentheses, tell you that what the hell is this? You know, in imperative language, where in normal actually languages, root start from top and it goes to down, like the grandparent, parent, child, like this. So let's say there is a, let's say my name is Ali and I am, and we say dots inside those imperative languages, especially in object-oriented languages. And they say, okay, this Ali, it's May, I hope so. And the age is like 35, something like this. So I'm going from top to bottom. It is the normal case inside all those imperative language. But in Haskell is different. It's kind of, since the Haskell, you know, is a math, very math friendly. Math is the language of nature. So they decided to go like nature. I mean, from the top to bottom, from the bottom to top. So the root here is CTX, and there is some like a script context. CTX is actually representative of a script context, and we are saying is CTX. We can choose any name or any convention for better use cases. And inside this, there is a method, or there is a function, or there is object. We can call it anything. Called script context TS info. But we are what we get just transaction information. So in fact, if you write this inside as a imperative line, we can say CTX dot script context info. And then inside this guy, again, there is another topic, and we can see it. Let's search this guy. There are another method, there are another types we can use it. So again, let's go to the first home page, Control S, and yeah, I think it should be a script. And you see the script context, which we say representative, it is CTX. There is something inside that, which is a script context TX info, the construct. So by doing that, we can actually take the somehow like getting the child stuff, like, okay, I want TX info. So now this guy produced the TX info, and inside the TX info, you see, okay, there is all sort of stuff here. So you see, in Haskell is kind of like this. So I said, I get this, and then I dot TX info, and where is it? And again, that there is a dot, and you can go like, where is it? Where, let's say there's a TX info output. To be honest, I'm butchering Haskell. You know, this is not good, but anyway, I'm doing it. So this is like this. This is in Haskell, and then we get this info as a TX info, as you guys saw that in that find data. And flip is just doing the position of the argument. It changes. Like this was the second argument, now is the first and second argument, first argument and second. And what is the second argument is hash. Is it TX out hash. So from on input, which we get from this guy, we get the TX datum hash. And get continuing is a function that just the TX out is the output, that they are the output, that the output, I mean, by output, I mean you are giving your Plutus input UTXO. And so you say, okay, consume this. And then it will produce some UTXO. Those UTXO are TX out. Those UTXO that you are producing will be the TX out. And get continuing output filter those TX out, those UTXO that will come back to your contract. So yeah, so this is, we have another function for getting all the TX out, which I used it here. I put all the TX out. By using this info TX info output, you get all the outputs, all the UTX. So it doesn't matter which address is going. But with using this TX continuing output, you will get only the UTXO, or only those output that is going to come back to your contract. And if we get, this is, when you get this, you're getting a list, because, you know, maybe there's 3 or 4 or something output out there. But you want one of them. Just why we want one? Because that's the whole purpose of this contract, to get one UTXO, which will have the state NFT produce new one. So it shouldn't produce 2 or 3 different UTXO, because if you do, you will lose the track of the UTXO. You have to put that NFT inside that. So again, we have also one NFT, so we have we can track one UTXO. If you have 3, you can go with 3 UTXO. So yeah, you can do it. 3 UTXO, 3 different estate NFT, and your contract can track. But right now it's just one. And then with this, the TX out, the output that we're getting, and if you see it in game instruction, here with TX out, you see that the second player is playing. We are saying that, hey, get this one, and there is a corresponding datum to it. What is it? This one. So if you use this switch, it will produce 2 things. First, the TX hash, the datum hash, which will be attached to this output, to this UTXO, and the file. So we are saying this file must follow a pattern that we very strictly define. Why? Because the first player, if he's winner, he wants to use that datum, and that datum must be following a pattern, and that pattern should allow you first player to put his choice, to prove it. So second player cannot create a datum that stop first player to prove. So yeah, so this is the datum that those functions get the datum hash of these, and the datum hash corresponding to this, which you will see, and it is attached if you query your contract address. And then we are providing that hash to this function, and then we get datum, not the game datum. So all of this was just get the datum, and then output of this, we are giving the output of this to this function, which we saw it here. And then this function will deserialize it to our game data. So we see that this will deserialize, and if it deserializes and everything is fine, the output would be game datum. So your beautiful, nice game datum that you are seeing here. And then you are free to go to comparing these types and do whatever you want, which we did here. Just one case that, hey, output datum should be equal with this pattern, with this style, not one way around. And as I said, this is why we could do it with datum. We say the data. But what was the problem? If we go with this, if we do not get the data for whatever reason, let's say the person here in this transaction that the second player is building didn't provide this. Let's say it was removed for whatever reason, you forgot. You won't get an error. You won't get a very specific error. You will get an error, but it is empty error. I mean, you get some kind of a strange languages error, and the content for the message is empty. So by using the maybe here, we are providing a way for error handling. And the error handling is if you didn't gain output datum not found. So we will tell the person, we will tell the second player that, hey, you didn't use this switch. You forgot that. Add that. So these are the ways that you can handle, and handling error is very critical in your business logic. And I know it would be very big. Maybe you don't want to do that. Maybe in your production, if you, I don't know. I heard that this one person did that. That this was their their contract in their glorious form, but the contract that they deploy, the deploying word is not that much correct in Cardano, but anyway, they use it in mainnet. They didn't have any of these errors. They remove all of them just to remove and to reduce, not remove, to reduce the size of their Plutus core, so the price and the execution as which you can see here in this. And if we just look at our contract, I think this was our contract, you see that we got a lot of steps, and this was very expensive in terms of execution. And one of the big reasons was we used the SHA, and SHA is a hash function comparing, and these stuff is really resource consume. So yeah, and there is a hard limit that we'll talk about in the next section, that if you pass that, I mean, you cannot actually use your contract whatsoever. But anyway, so yeah, I mean, maybe it's removing this can help you a little, reducing, but it's better to handle that. So this was about this, and I had to go because this was outside of the Plutus, so I just go with that. But I'm seeing that most people left. Do you have any question? And I passed 9 minutes from the deadlines. I can continue this from to tomorrow or next session. So do you have any question, guys? No? Okay. So this is, I think, around, like, I don't know how long would, I think there is 2 hours, 12 minutes that's recording. So I'm going to stop this session. It's 2 hours already, and we'll continue to talk about other stuff and go into the definition section, condition section, and template and INLINABLE. And we touched some of these already, but yeah, I mean, we will talk about more deeply inside that. And refactoring a smart contract, we are going to refactor this very simple security check that I wrote it here. Where is it? This guy. We'll do it together. And then I hope we can touch some of the topic, like looking at Plutus core. So we'll decode this together. This is the code, and we will see that what information we can get out of this. So what vulnerabilities can happen, what you have to actually hide, and you shouldn't put in your Plutus core, and you shouldn't put inside your game parameters because it's exposed. And then we look at some spot contracts, SQL and binary and decoding addresses, and some hard limit. I hope we have time. I don't know this is that much related to our module about double satisfaction vulnerability, but maybe we will talk about that too. And script purpose, which we'll talk more deeply about how you should define your business logic around the proof of stake of Cardano and using I think the script purposes should be here somewhere. Script context and how to I mean using rewarding a script and certifying a script, which you can write both with Plutus and like what's happening in 0-1 game, that we had a minting. Let's say this minting command which we use for a set NFT was actually a script, Plutus script. So we somehow integrate or minting a script with or spending a script. As you can see that we provide this currency symbol, and currency symbol, as you know, is the hash of that script. But the integration, as you can see, is important because of a state. So I hope in the future we will create a module about how to write a rewarding a script and certifying a script. So in that, you can integrate your rewarding a script and your certifying a script inside your spending scan Plutus score. So yeah. Okay, CEO Curtis, I'm going to finish this session too. Thank you for time. I know it was very late. So take care, guys. And if you guys have any question, I'm here, but just I'm going to stop sharing. Okay. Take care, guys. Nicolas, Sebastian, Curtis. See you. And James, if you are here, I don't know, James, are you? Anyway, take care, Sebastian. Thank you. Bye.
Excellent, man. Excellent. I have to ring.
Okay.
A pair of.
But if you have any question, you can tag me in Discord, or yeah, I mean Discord if you have any question about this.
No, I don't have no question.
No problem.
Thanks, man.
Okay. You're welcome. Take care. Bye. Goodbye.